Okay. All right, so correct we had 125, and incorrect was 274. All right. Okay. So 7-4. Last lesson is hypothesis testing for proportions. So this is the procedure we're going to use. You're going to notice it's really similar to what we've done already with hypothesis testing for means, which is what we did in 7.2 and 7.3. But now everything's about proportions, so you're going to see percentages that claims are being made about. Less than this percentage, more than this percentage, equal to this percentage. Because it's a proportion now, our conditions at the start are a little bit different. What we need to check at the beginning, we're not looking for normally distributed greater than 30. We're looking for this, that NP is greater than or equal to 5 and NQ is greater than or equal to 5. When we did confidence intervals, we used P hat and Q hat, which were the sample P value and Q value. In this, there's not a little hat over it. So this is just the P value that you're hypothesizing about and the Q value that goes with it. Remember, they're complements of each other. Step 2, we're going to do the claims as usual. Step 3, level of significance will be given to us. Step 4, critical values are going to be Z's always for this. Okay. We're going to use rejection regions, so it'll be either left tail, right tail, or two tail as we've practiced, and we'll draw those rejection regions with our critical value. Then we're going to find the standardized test statistic, RZ value, that we can then compare to that rejection region, and this is the formula that we use. So the numerator is still the same as what we were doing with our means. It's a sample minus the population, and the denominator is still a margin of error, but when we did proportions, we did the margin of error a little bit differently, so that's why that looks like it does. And then if we're in the rejection region, we reject. If we're not, we don't, and then we summarize from there as usual. Okay. So let's look at our M&M data. All right, so the claim is that students can guess the correct color of an M&M 14% of the time. So this is not a greater than, less than situation. This is approximately 14% of the time it is guessed correctly. So the first thing we're going to do is write the null and the alternative hypothesis. Okay. Is the claim a null or alternative?
Null.
It is a null. We're saying that the proportion is equal to 14%. Remember, we always use a decimal for these. Label it the claim. And then our alternative hypothesis, if we're not equal to, we are not equal to. There we go. And I can also label right now if it's a left tail, right tail, or two tail test. This is a two tail test. Find the standardized test statistic using our class data. So this is not, well, it actually doesn't even say standardized. I put that in my brain and that's not what it says. It just says test statistic. So it's just asking for the P hat value here. So this is the sample proportion based on the data that we had. So you guys had 125 correct, so 125 successes. And then the denominator is the total number of guesses. So we need to add up the 125 and the 274 to get our N. 125, 274, 399. Oh, so close. All right, and then we divide. I'm going to give it 3 decimal places. 0.313. Okay, so you guys guessed correctly about 31% of the time. All right, test the conditions for the hypothesis test. So you need to look at NP and NQ and make sure that both of those are greater than or equal to 5. N was 399, and P is the claim, the number that our claim, our proportion is being made about. So 0.14 is our P, and let's multiply. We got, I'm just going to approximate here, about 56. So that guy's good. If P is 0.14, what's Q? It's complement. 0.86. So 399.86, about 343. Okay, so we're good on those. Okay, Next, using a level of significance of 0.05, find the critical value in sketch rejection regions. All right, so we need our chart for this. It is a two-tail test, level of significance 0.05. So remember on the Z chart, we had those common ones that you guys wrote in. So that's what we're looking at. 0.05, two-tail, I get critical values. And remember, our book uses a Z sub 0 for these, is plus and minus 1.96. And then you can sketch that, positive and negative 1.96. Questions there? Okay, so that's just like what we did before. All right, continuing on to the next slide on your paper. Now we're going to calculate the standardized test statistic, which is the Z. All right, here's the formula we use. P hat minus P over a margin of error, which is P, Q over N. And this stuff we've already calculated on the previous page, so I've got to flip back and forth, so pardon me. All right, so P hat was 0.313 minus our P was 0.14, what we were hypothesizing about. It's always sample minus population. And then we had 0.14, 0.86 for our P and our Q over N, which was 399. All right, 0.313 minus 0.14. I get 0.173 on the top. On the bottom, divide by 399. Take the square root, I get 0.0174. Divide that in, I get a Z value of 9.959. Okay, that's pretty big. Are we going to reject or not reject? That is in the rejection region. So we are going to reject the null hypothesis and then explain. You could just say because our standardized test statistic is in the rejection region. Standardized test statistic is in the rejection region. Okay, so then interpret that decision. Do we have or do not have enough evidence? Is there or is there not enough evidence? There is evidence to reject the claim that 14% of the time the color is guessed correctly. So based on your data, your experiment, we have said that claim is false. We've rejected it. Why is it false? Why is it false based on the data we had? What did our data say? Yeah, we guessed at 31%. And they were saying we're hypothesizing we're going to guess about 14% of the time. So are those numbers even close to each other? And that's why we're getting such a very large Z value here, because we were way over what we're hypothesizing about. Now, if you had had 15% or 16%, we might not have had enough to reject it. We would maybe be able to support that instead. But because we were so far above what was being hypothesized, it was rejected. Okay, now you could also change what the hypothesis test looked like. You could say we hypothesized that more than 14% of the time we would guess correctly, and then we'd probably have a different result. But because it was an equal to, not equal to situation, and we weren't really close to that number, above or below, that's why it's rejected. Okay? Any questions on this? All right, we're going to do one more. This one won't be as lengthy now that we've practiced one. Okay. A researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 100 adults, 41% say they use passwords that are less secure because complicated ones are too hard to remember. At a level of significance of 0.01, is there enough evidence to support the researcher's claim? All right, so things that I need from this information. I need an N. What is N? 100. I also need to start a P and a Q because those are the pieces I need to make sure I have enough information to be able to do the hypothesis test. P is the percent that you are hypothesizing about. So here it's 0.45. That's what the claim is being made about, which means Q is going to be what? 0.55. So let's go ahead and test NP and NQ as our first step to make sure that we meet the conditions we need to. So this will be nice and pretty because N is 100. 100 times 0.45 gives me 45. And 100 times 0.55 gives me 55. Both of those are greater than or equal to 5. So we meet our conditions. Okay. Let's write hypotheses next. Null and alternative. So the claim is that less than 45% of US adults use passwords that are less secure because they're too complicated to remember. So because it's a less than statement, is that going to be my alternative or my null? It's going to be the alternative, and remember we're using a P here, okay, for proportion. P is less than 0.45. That is my claim. So my null is greater than or equal to 0.45. Left tail, right tail, or two-tail test. This is a left tail test for my alternative hypothesis. Okay, let's see. Next, let's go ahead and get our rejection regions. We have a level of significance of 0.01, and we have a left tail test. So 0.01 left tail, my critical value of Z is negative 2.33. Always Z charts for these. That's going to be down there somewhere. Okay. Then we need to calculate our Z value. P hat minus P all over the square root of P Q over N. P hat is given to us. We don't have to calculate it this time. They told us the sample percentage was 41%. Hi, this is Miss McDonald. Hey. Yeah? Okay. No. Stacks is doing theirs a week and a half earlier on the night. I had sent you, I think, 2 emails originally, and Stacks was the first one, and then one with Julie and Misty was the second one. 7:45 to 9:45. And there's about 60 kids. That'd be great with me. Okay. Perfect. Thank you. Bye. Okay. All right. So P hat sample proportion they gave to us 0.41 minus 0.45. Our proportion that we're hypothesizing about, 0.45, 0.55 over 100. So I'm going to get negative 0.04 on the top. On the bottom, get 0.0497, divide negative 0.804. Okay, so is that in my rejection region? No, so our decision is fail to reject, or you can say do not reject the null hypothesis. So then the summary, there is or is not enough evidence to reject or support the claim. There is not enough evidence to support the claim that less than 45% of the US adults use passwords that are less secure because complicated ones are too hard to remember. Okay, questions on doing a hypothesis test with a proportion with rejection regions? All right, when it gets to test day, all of your hypothesis tests that you're going to do are with rejection regions because we don't need technology to do them. But Math Excel and your project that's coming up next week. Did we talk about the project in here yet? Okay, we're going to talk about that in a minute. When the project comes up, you will need to use technology for a couple problems. So you need your calculator for this one. Okay, so for the problem below, it says determine whether a normal sampling can be used. If so, test the claim using technology. So before we get to the calculator, we need to check our NP and our NQ. That's what it's talking about to make sure our normal sampling is going to work for this, so we can do the hypothesis testing. They give us N, it's 90. P is 0.48, what we're hypothesizing about. That's in our claim there. So that's going to give me 43.2, so that guy's good. So if P is 0.48, Q is 0.52, which is 46.8, also good. Okay, so normal sampling can be used. My sample size is large enough, we're all set. All right, what else do I need in my calculator? The other thing that we're going to need is an X value when we type this in our calculator. We have P hat, and the formula for P hat is X over N. So I'm going to fill a couple things in here. So P hat, they're telling us sample proportion is 40% of whatever. X we don't know, which is the number of successes for whatever we're measuring. And then N is the total sample size, 90. So you're going to need X for the calculator. You can very quickly get it just by filling in two of the three things you know in this formula. So if I multiply by 90 on both sides, I'm going to get X is 36. Nice pretty number there. Okay, so what we want to do is use the calculator to get the other p-value that we used, which helped us then compare to alpha to decide if reject or not reject is our decision. So how we're going to get this is we're going to go into stat again. We're going to go over to tests, and then you probably want to make a note. We're going to choose option number 5 this time. Okay, so this is a 1 proportion z-test, bless you. 1 proportion z-test. So z-test and t-test at the top we used if we were hypothesizing about a mean. Option number 5, because we're hypothesizing about a proportion, that's why we're choosing this guy. Okay, and then things it's going to ask us about. So p sub 0 is your p that is in your hypothesis, so it's 0.48 in this problem. X we just solved for, that's 36. N we were given, that's 90. And then, we don't know if this is a left tail, right tail, or two tail test. Can you guys tell me if it's left tail, right tail, or two tail? How do you know it's left tail? Yeah, so the null is what I'm given here, which means the alternative is less than 0.48, which tells me it's left tail. Yeah. Okay, and that option is the second one that's highlighted there, the less than option. We're going to go down to calculate. And it spits out this information for me. Okay, and the p-value from this is what we're looking for now. Okay, so that p we're going to compare to the alpha and decide if we're going to reject or not reject. Okay, so p is 0.064. Alpha from the problem is 0.08. So in this case, p is less than alpha. Do you guys remember what decision we make if p is less than alpha? We decide to reject if p is less than alpha. If p is greater than alpha, we do not reject, and then you can summarize. We don't have a context to summarize here, so I'm not really worried about it. We're only going to do one of those two, so I'm not worried about that second one. Any questions in the calculator? Getting that? All right, so those Math Excel problems will say use technology. That's how you'll know to do it this way. Okay, last problem I put in here, again, just to kind of prepare you for your upcoming project. When you do your project, you're going to have some hypothesis tests and confidence intervals to do, but you also have to make your own hypothesis test about a proportion. So this says create a hypothesis test with proportions about high school seniors, write a null and alternative hypothesis, label which is the claim, and then we're going to determine a level of significance ourselves and explain why we made that decision. Okay, so make a claim about high school seniors, something that has to do with a percent of high school seniors. This percent of seniors did this, or at least this percent of seniors, or at most, or more than, or less than. It has to be about a percent, though. What do we want to hypothesize about? What percent of seniors are trying to get Taylor Swift tickets today? How about that?
Yeah, let's do that.
What do we think? 45% equals to, less than, greater than? Less than? Okay. Less than 45%? Okay. Maybe a little smaller? 15? Okay, less than 15% of high school seniors are trying, the computer's slowing down on me, to get T Swift tickets. Got it. Okay. Is that a null or alternative hypothesis? That is an alternative hypothesis. So my proportion is less than 0.15, and that is my claim. Okay, what is the null hypothesis then? P is
Greater than.
or equal to. Oh, I'm sorry. Didn't hear that part. Okay, got it. Yes. Good job. Okay, any questions creating the hypothesis test? Okay, the other thing that we have to think about is our level of significance. Now, if I were picking a level of significance for these problems, I for sure would pick one of these three because in statistics they're the most common, but they're also ones that you have z-values for in your chart already, so it's less work. Now, which of these you pick is up to you. There is no wrong answer for this as long as you justify your answer. The smaller your alpha gets, the less likely you are to reject, which remember is ultimately what we want to do, but you're also less likely to have an error, that you reject something that really shouldn't be rejected. The bigger your alpha is, the more likely you are to reject something, which is good, but more likely to reject something that shouldn't be rejected. So on either of these ends, you could end up with one of those type 1 or type 2 errors. So you could stick middle ground. So you could say, you know, playing in the middle of having a type 1 or a type 2 error, but still a small level of significance, because the smaller our level of significance, the less likely we are to have an error in general. Okay, and all of these are pretty small. So literally, you can get easy points for this problem. I really can't mark it wrong as long as you justify whatever your decision is. Okay?
Wait, so if I put 1, 0, what would I put?
You could say I chose that because I'm more likely to reject the null hypothesis, and that's what I want to do in this problem. Okay, or you could pick 0.01 and say I'm less likely to have to reject something that shouldn't be rejected. That's what I want to do in this problem. So it depends as like a researcher or a statistician what you want to do. But again, all of them are good. That's why they're all commonly used. So no bad decision there. Okay. We'll do cell phone lotto real quick. Couple things. Tomorrow we're going to start test review. We're going to review for 2 days. Test is 2 days, Friday, Monday. All of the test review stuff's online if you want to start looking ahead at stuff. Then 18 is my cell phone lotto winner. All right, then on Tuesday, you guys are going to start your third project. It won't be due until like the Friday after we get back from break, so you'll have some time. You'll have 2 full days in class to work on it. For your last project, you need to collect some data before next Tuesday. You need to collect before next Tuesday 50 temperatures, 25 male and 25 female. You do not have to take their temperature yourself. You can just put it on your story and say, take your temperature and tell me what it is, and then use that for your data. That's fine, okay? You don't feel like you have to be like walking around with a thermometer through the hallway. But 25 males, 25 females, I don't care when you take the temperature. If you want to do it at sports practice or early in the morning, or if you want to just be all over the place, that's okay too. But we all need that data when you walk into class on Tuesday next week. So be thinking about that, okay? All right. Okay.
I have one question for now.
Yes.
So, for
know this one. I kept getting this wrong on Math Excel.
Okay.
What is it? It's in front of it, so that's why it's not an effect. What if it's negative 4? I thought this was so for this left hand, I just like everything over here was checked.
So left tail, anything in the left tail.
We did a Math Excel. Wait, we have 2 Math
7,
Excels.
3 Math Excels due tonight. If you haven't finished it yet, you should be close to finish that one though.
I did
And
it.
7-4 is due tomorrow night.
9 and
7-4 is due tomorrow night.
When do we get our?
I'll give you your assessment.
Because then I get the.
So you're gonna be here on Friday class.
Yeah.
Right, I'll get you Friday class.
I can do it.
Yeah, and like I said, it's not due until the Friday after we get back. I think the Tuesday we get back is a work day too. So, I mean, don't feel like you really don't need to do it for free if you don't want to. It's okay. All right.